going to continue to the LDL, like dissolve like part 2. Okay, so in here, this picture that I beautifully made is actually trying to replicate this. Okay, so as you can see in here, the tail, let's say the tail, the non-polar part, the hydrophobic part, will then lift up the dirt, and water is in here, so they have this interaction. So again, the polar, this is not really a correct description if we say polar, because it's actually ion in here. It's not polar. Remember, polar is also, always referred to partially. Yeah, pole, it's partially, either partially positive or partially negative. In this case, it's not really correct to describe that, because it's actually ion negative, as you can see before. But still, the negative will be able to interact with water, because the characteristic of water has a negative pole as well, so they actually like dissolve like. So yeah, this is the way. Then this is like lift up, this is able to, this is not the connection in here, that happen. Okay, why is able to lift up like that? The connection in here, basically, guys, water, because there is interaction in here, water will then kind of pull up this side, because water is in here and then water is in here. That's why it will lift up there. Soon as the surface is lift up, the other soap molecule will then fill again the non-polar part of the dirt with the tail. So overall, it will be lift up like this. So when you rinse your hand, it will go away alongside with water, because water will go away as well. So this is the mechanism of how soap molecules able to lift up or clean dirt from your hand or from your shirt, your dirty laundry and everything. So that's how it happened. Now let's go to the end of this video about the virus. Remember, the statement question is to what extent actually intermolecular forces able to kill the virus, to eliminate them. So one fact in here that you have to know, virus, or we focus on virus first, they have this membrane, this is what we call it, membrane. It's kind of layer that separate the inside part of the virus to the outer environment area. So what you have to know, that this membrane, many virus has this membrane. The characteristic of that membrane is actually non-polar. So basically, this membrane usually consists of fat. Fat is also non-polar. So if you then, have you ever like dissolve like fat from, like, maybe, I don't know, kikil, not kikil, some food that has bakso, they usually have fat in there, like the white one. They basically a non-polar. It will dissolve in oil and stuff. So this is non-polar side. So let's have in here, this is the membrane. Okay, this is the membrane of the virus. Oh, sorry, the membrane, the non-polar usually described with yellow. I mean, for the consistency sake, it's like oil, it's like yellowish, something like that. So fat also like that. So this is the membrane of the virus, and in here there is the genetic and everything that will destroy our cell and blah blah blah. So imagine this membrane is a non-polar, so actually it's like a dirt, because they have a non-polar surface. So what happen will be the same thing. So the tail of the soap will then attract with this membrane, and water then will pull apart these all. So this is the tail again, and then this is the head that like water. Water will attract this negative, remember this is negative negative. So basically it's kind of put anchor on the membrane, and then after that it's then, you know, pulled by water, and you will expect then this membrane will be destroyed by the intermolecular forces. So this is uh, what will look like this part. So water in here later on will just, you know, pull apart this everything. So this gonna destroy the membrane. After the membrane destroy, of course the inner side of this will go out, and they basically broken the virus. Okay. So uh, this is not happen only in this side, yeah, the other side as well. There is soap in there. This also, there is soap in here, there is soap in here. Yeah, this is the soap, and this is the water, this is the water, this is the water. So basically it will literally shredding apart the membrane and expose the inside component of the virus. So basically it will just destroy the whole structure of virus. Is that like, it's really really interesting, right? So then later on, um, the soap will then uh, leave the surface, maybe your hand, after you rinse your hand, and will go away, and the result is your hand will be very very clean. So in here you will have, this is the intermolecular forces that happen. This is dipole to ion interaction, dipole to ion interaction, because this is water. So you expect this is negative, right? So the one that will interact with negative is obviously the hydrogen, as you can see. Sorry, yeah, the hydrogen, uh, the hydrogen in here is going to be partially positive, as you know, partially positive. So they will there is positive negative over, there is attraction in there. That's why it's going to be like pull up away, pull apart, destroy this. So this is dipole from the hydrogen, the pole from hydrogen. So it's not dipole, sorry, it's pole to ion from the uh, soap itself. And then in here there is also interaction between non-polar to non-polar. Okay, this non-polar to non-polar interaction resolve in uh, like dissolve dissolve like. So basically it will dissolve the membrane, so these interactions, there are two main interactions: the tail of the soap with the membrane. So let me write in here. Oh, sorry. So the first interaction is between the tail of soap, or in a more scientific way we call it the hydrophobic of the soap, with the membrane, or you can call it fatty membrane, fatty membrane of the virus. This is a non-polar to non-polar intermolecular forces intermolecular force, or in more scientific way we call it van der Waals intermolecular forces. Intermolecular forces. Okay, and then the second intermolecular forces sorry, the second one is actually between the head of the soap, or in more scientific way we call it hydrophilic side of the soap, with the water. The interaction in here is between pole to ion. This is the interaction molecular forces. This is actually pole to ion is similar with when you have salt dissolve 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 in water. The previous example, if you have salt dissolve in water, it's easy, right, to dissolve salt in water. Why? Because salt and water, salt is Na plus and also Cl minus. Of course it will, the plus of course will have interaction with the negative part of the water, negative pole, so oxygen. So this is negative, but the chloride in here will have interaction with the positive, which is water, the plus. So this is similar with the second interaction of soap destroying the virus. Okay, so again, as a recap, so the tail of the soap will then attach or attract to the fatty membrane of the virus, and additionally, this first point will this is already able to destroy the virus, and there is the second additional interaction in here where now the head of the soap will be attracted to the water. It will create the effect of pull or shredding to the membrane of the virus. So you imagine this is like you put anchor in it and you pull away. The putting anchor is the first interaction. The pull away from the membrane will be the second interaction. So it's very, very effective. Thank you very much, everyone. I hope this can help you to do your work. Of course, you have then later on mention or explain or describe the limitation of this. Remember, this need water. It's not every time you have water available with you. So maybe one possible limitation for this mechanism to happen is when you cannot or you don't have water with you, so you cannot do this mechanism. So yeah, I think that's all. Hopefully it's clear. I will add also another video from other sources to help you. Thank you, everyone.